All right, so again, 9-1 is linear and nonlinear systems of equations. So we're going to start with the first method of solving systems of equations, which was substitution, and then the next section gets into graphing and elimination. So notice that it says linear and nonlinear. Like linear means that my x and my y are going to be raised only to the first power, and then nonlinear means they could be squared and cubed and that kind of stuff. So we'll start with the linear, and we'll start with substitution, and then we'll work our way through it. So to solve using substitution, this is the first of many methods you're going to learn for solving a systems of equation. You're going to have two equations with two variables. So you're going to see an x and a y in two equations. That's what makes it a system. And then you're going to either solve, you pick whichever equation you want to pick, and you solve for whichever variable is the easiest to solve for. And then you take that, whatever it equals, and you plug it into the other equation in place of that variable. You're going to solve for the one variable that's left, and then you take that solution and plug it back in to the either original or the one you solved and get the second answer. And then these are going to be written in XY coordinate point form. So your answers will always be that kind of form. Not x equals y equals, but actually in your coordinate points. All right, so it says just solve the system. And this time it says use substitution. Eventually it will just say solve and you'll get to choose sometimes. And then there's going to be methods that are forced. This time, obviously, we want to use substitution because that's what this section is. So I want to look at the two equations for number one and figure out, is it easy to solve for one over the other, and then which variable. So pick one. The x for the first equation and the second equation. First. Okay, so I'm going to take this equation. I'm going to solve it for x. So I would get x equals 4 minus y. And then you're going to take that and you're going to plug it into the second equation in place of the x. So this goes in place of the x. I get 4 minus y equals 2. 4 minus 2y equals 2. Subtract the 4. Negative 2y equals negative 2. And then divide by negative 2. And y is 1. So that's the first part. And then I want to take and plug that back in. And you've got choices. You can either plug it back into the original equations in either one, or you could plug it back into the equation you already solved for that other variable. Usually that's probably the easiest. So I'm going to plug it back in there. X equals 4 minus 1, and x would equal 3. And then my answer goes 3, 1 in order x, y. The good thing about systems of equations is that every single one of these answers can be checked. So I can take all of these and I can plug them back in to these equations. So if I wanted to check, if I had extra time and I wanted to check it, I would get 3 plus 1 equals 4 and 4 equals 4. That works. And then I would do 3 minus 1 equals 2 and 2 equals 2, and that works. So you do not have to check them. It's not like there's an extraneous root possibility. But these are easy to check if you've got the extra time to make sure. This is why standardized tests, like sometimes you work backwards, it's faster. Sometimes just plugging in is where it works better. You most likely will not get a multiple choice test on this one. But if you did, those are easy to check. All right, go to 2. So again, pick one equation and solve for one of the variables. Which equation do you want to solve? So I would definitely not choose the bottom this time, right? Because the bottom, they're not already isolated. So I would say, okay, I'm going to use the top, and then you could solve for either of them, x or y, right? So you're saying y?
X.
Okay, so I'm going to just move the y to the other side. And then I'm going to take the y and plug it in place of the x. And I get 5y minus 3y equals 6. 2y equals 6. Divide both sides by 2, and y equals 3. So again, that's the first part. And then I'm going to take it and plug it back in, and I can plug it back into either the originals or the one I already solved for x. So I could just say that x equals 3 as well. And there's my solution point. Check it here. 3 minus 3 is 0. 5 times 3 is 15. Minus 9 times 3 is 9. Or sorry, 3 times 3 is 9. And 6 equals 6. So it works in both of these. Questions so far? Easy stuff, right? We remember this stuff from Algebra 1? Yeah. All right. Then you're going to get them in word problem format. So most of the time it has something to do with money. It doesn't always, but it has something to do with money. These are interest problems. It says a total of $12,000 is invested in two funds, paying 5% and 3% simple interest. The total annual interest is $500. How much is invested at each rate? So your two variables are going to be the money invested at each of those accounts, right? So let's say I say X is the amount invested at the 5% and Y is the amount of money invested at the 3%. They're giving you two basic pieces of information. One, the total amount invested, which is that $12,000. And then the other is the percent that's actually earned, or the interest that's actually earned. So if it's a total investment of $12,000, that means X plus Y equals $12,000. And that's one of the equations from your system. And if you earned $500 of simple interest, that means that 0.05x, which is what it would look like as 5%, plus 0.03y equals 500. So to get from percent, you can't leave percent in your equation. To get from percent, God bless you, to decimal, you're going to move your decimal place 2 places to the left. Now I've got this system. So because we're on the substitution section, we're going to solve this using substitution. You actually have a choice here to get rid of the decimals in the bottom. So if I wanted to get rid of the decimals in that second equation, what would I multiply everything by? Close. 100. So I got to move it 2 spaces, and be careful here because this people tend to do right, but then they forget to multiply the other side. So this would be 5x plus 3y equals 50,000. Add on your 2 zeros. And then x plus y equals 12,000. Okay, so now I want to use this system. Which equation are you going to pick to solve for? Second, I would definitely obviously recommend not having to isolate the 5 or the x or the y in the first one. And which variable you want to solve for? Let's solve for x. So x would equal 12,000 minus y. And then I'm going to take that and plug it in here. So 5 times 12,000 minus y plus 3y equals 50,000. Distribute this in. So 60,000 minus 5y plus 3y equals 50,000. Combine your like terms. Subtract the 60,000. I get negative 2y equals negative 10,000. Divide by negative 2. And y is 5,000. So that's how much was invested at the 3%. So $5,000 at 3%. And then I need to find out how much invested at the 5%. So I can go back to the one we solved for x. X would equal 12,000 minus 5,000, which is 7,000. Questions on that one? All right, so what are your 2 equations?
X plus y equals 25,000.
Good.
65x plus 85y equals 2 million.
Okay, so you moved it. So it starts as 0.065x plus 0.085y equals 2,000. And then you multiply by 1,000. So 65x plus 85y equals, and you're adding on 3 zeros. And then x plus y equals 25,000. And then what variable do you solve for?
X.
X. So you did x equals 25,000 minus y. Take that and plug it in here. So 65. 61625. Zero. All right, so the amount invested at Y is 18,750, and then X is going to equal 25,000 minus that. $6,250. So I think that's what I was checking. WebAssign will say like how much invested at this and invested at that. So it would say like invested at 6.5%, and that's what we've made the X. So this would be $6,250, and then invested at 8.5%. That's what we made Y 18,750. So I would say just pay attention to directions, especially on systems of equations questions. It might just only ask for one. It might just say like how much was invested at the 8.5%, or it will use words like higher yielding or lower yielding. So if it says like how much was invested at the higher yielding account, higher means like the more money you're earning. So that's going to be your 8.5. If it said the lower yielding, then it would be 6.5. And sometimes, obviously, if it's only asking for one thing, that changes how you solve. Because if I was only asking for Y, then I would try to solve like we did for Y first. If it was only asking for X, then I would make sure that I can solve for X first. So just make sure that you read all the way through, kind of get a plan before you start to go through these questions. You'll see systems of equations questions with like ticket sales and like coins, like you have $20 and nickels and dimes. You have so many of these and so many. So that's like all of those are systems of equations questions. Standardized tests love those kinds of questions. So just, make sure you get comfortable with setting up your own system and then solving it. Questions where we're at? Okay. So non-linear systems mean that there's going to be an x squared or an x to the third or y squared or something like that. These are systems with exponents, and they can have more than one solution. So which in the homework you'll see it will say solve using substitution and then graph to check your answer. So we're going to do a couple of those. But if I had, let's say I had an equation that was in a line, and then I had an equation that was a parabola. So if my one is a line and the other is a parabola, there are 2 points of intersection, right? That kind of question is going to have two answers. If they were to be something like a line and a parabola that never intersect because the parabola points the other direction, this would be a no solution answer, okay? So it could have two solutions. If it was a cubic function, it could pass through 3 times. It could have 3 solutions. There's no rule on how many solutions it can have. And if you are solving these, obviously if it's 2 solutions, you're going to get 2 x's or 2 y's, and then you'll plug back in 2 x's or 2 y's. But a no solution situation, when you're solving using substitution, means that both variables cancel out. And what's left is a false statement. So if both variables cancel out and I end up with 0 equals 3, That's what I mean by false statement. Okay, obviously that is not true, and that would be a no solution possibility. So that's one special case. The other special case is in all real numbers. And that happens if both variables cancel out. And it's a true statement left. Like 0 equals 0. So that can happen while you're solving it using substitution. If you were to graph it, it would look something like this. Like either you're going to get a crisscross of either whether it's two lines or two parabolas or a line and a parabola, whatever those graphs are. Wherever they intersect would be your answers. If they never intersect, if they're parallel lines, or if there's something like that where your parabola is pointing the other direction, they never intersect, that's when it's no solution. If it ends up being the same line, that would be an all real number scenario. Anybody still covering that down? All right. So 5, and the directions again on these will say, on the homework it says solve using substitution or solve, and then it says use a graph to check your answer. Not all of them. There's 3 like that, I think. There's 4. Check your solutions graphically. So we're going to do both. We're going to solve this using substitution, and then we'll graph it. All right, so now if I look at these 2 equations, obviously there's something squared there. I don't want to solve that. I don't want to solve row 1 for x. I'd have to move. There's 2 there that I'd have to either try to factor it, right? This could be a mess. So I typically would obviously pick the other side. You can either solve for this y by isolating the y, move the y to the right, and then move this 7 back over. Or I can solve for this y and take and plug it in. If I solve for this, the second y, let's just say what that looks like, right? This would be 2x equals -1 plus y, and then I add the 1, and I get y equals 2x plus 1. I am taking this, and I am plugging it into, oh no, that's not that. I'm plugging it into the y. If I had taken the bottom row and solved it for x, I'd have to plug it in here, and I'd have to plug it in here. I'd have to expand and FOIL it in the top and then distribute, okay? So sometimes there's an easier route to take. You want to make sure you pay attention to that. It doesn't mean it can't be done, and sometimes you can't avoid it. You're going to have to plug in and expand and FOIL. But in this case, it's much easier to avoid that. All right, so now I'm going to take and solve for y, which I did, and take and plug it into the first equation. So 3x squared plus 4x minus, now that minus is going to go to both of those terms. So be really careful because that's a really common mistake. This gets distributed to both. I get 3x squared plus 4x minus 2x minus 1 equals 7. 3x squared plus 2x. This would come over here. Well, first of all, it would look like this. And as soon as you see that there's a squared and a non-squared, that's your hint, you're going to have to factor, right? So I'm going to get everything, or at least try to factor. I'm going to get everything to one side. Subtract the 7. And then I'm going to try to factor this. So I would do first times last here. 3 times -8 is -24. Are there factors of -24 that sum to 2? Positive 6, -4. Plug those in. And factor by grouping. Take out a 3x here. X plus 2. Take out a -4. X plus 2. And then x plus 2 and 3x minus 4. And then I split and solve. So x equals -2. 3x equals 4. And x equals 4/3. So 2 answers there. One where the x is -2. And one where the x is 4/3. With me so far? Now I got to take and plug each of those in. So I'm going to use the equation we already solved for y. I would get y equals 2 times negative 2 plus 1, negative 4 plus 1, negative 3. And y equals 2 times 4 thirds plus 1, which is 8 thirds plus 1. 1 becomes 3 thirds, and this becomes 11 thirds. All right, now we're going to graph it. So if you have your graphing utility with you, get it out. If not, you could do this on the app, but obviously if you've got your calculator with you, that's the better option. All right, so first of all, in order to graph these, they both have to be solved for y. We solved the bottom one for y, but we did not solve the top one for y yet, so I've got to do that. I got to isolate this y. So if I move the y to the other side, I get 3x squared plus 4x equals 7 plus y, and then subtract the 7. So again, we've got to isolate the y's. So we're going to plug in these two equations. So y equals 3x squared plus 4x minus 7. And then y equals 2x plus 1. All right, so I typed them in, and then I hit graph. There's the parabola, so that's the top one. And then there's my line, that's the second one. So if I wanted to find exact intersections, I go I go second, calc, which is above the trace menu, and I go to intersect. It's asking you for the first curve. So it doesn't matter which one you pick as first and which one you pick as second because there's only 2. If there were 3 graphs here, we would want to tell it which ones I'm trying to pick. So I went second, trace, and I went to which is the calc menu, and I went to intersect. Okay, so I'm going to say first curve, that's fine. I'm going to pick the blue one as my first curve. Second curve is the red one, that's fine, hit enter. And then it says guess, and I hit enter again. And it's going to bring me to my first point of intersection. Now that is 1.3 or 1 1/3, which is my 4 thirds. And then 3.6 repeated would be 3 2/3, which is my 11 thirds. Now I want to find the other one. So I'm going to go second, trace, go back to intersection, which is 5. This time I'm moving more towards the other intersection. So again, it doesn't matter which one you pick first or second. But you got to move it more towards the other intersection. I did the blue one first, then the red one, and then I hit enter on the guess, and then it brings me to the other point, which is -2 and -3.
And this is just to check. Right?
Just to check. In this section, you don't have to graph anything by hand. There's 4 questions that say solve, and then use the graph to check. So that's what you would be using it for. In the next section, we're going to learn how to actually graph and find the solutions. I don't think so. It certainly would not. It's either going to be in 2 parts or it's going to be none because the graphing ones you have to do by hand. Yeah. The other way that you can see these solutions is to go to the table. So if I hit second graph and I go to table here, now that catches, this is only going to show you your whole number answers. It's not going to show you your decimal answers. So if I see the same X and Y, or the same Y for Y1 and Y2, that's how I know it's the same solution. So if I scroll up, if you look at -2, notice that the Y1 and the Y2 are both -3. That was one of my solutions. Again, this is only showing you the whole number solution. So you'd have to be able to find the decimal one using the trace. But that's always an option. Questions? All right, you do 6. All right, so we graphed them to check. You do not need to graph on the homework to get the answer. You don't need to include the picture in your homework as your answer. You are simply just graphing to check it. So it's just practice to graph it, okay? And it will, like, it gives you the space to put your solution, and then it gives you, it'll just say graph to check, that's all. So you don't need to, it's literally just to check it. And you can either use your, graphing utility, your handheld, or you can use the app. All right, so 7, same sets of instructions. You want to solve using substitution. So I want to pick one equation and one variable. Which one would you pick? First equation, what do you want to solve for? Y. Okay, so y equals 4 plus x. I'm going to take this and I'm going to plug it into the y in the second equation. X squared plus 4 plus x equals 3. And I end up with x squared plus x, subtract the 3, plus 1 equals 0. Are there factors of 1 that sum to 1? No, so this cannot be factored. It's still quadratic, which means my backup option is what? Quadratic formula. So negative b plus and minus the square root of b squared minus 4ac over 2a, where my a is 1, my b is 1, and c is 1. So I'd get negative 1 plus and minus the square root of b squared minus 4 times a times c all over 2 times 1. I get negative 1 plus and minus the square root of, this is 1 minus 4, negative 3 over 2. So if this was just a solve and this was like find any solution, there's an I here because of that negative. And I would get negative 1 plus and minus I square root 3 over 2. Can I find this solution on a graph? No, because it's I. So there is no real solution here. If the directions had said, like, find all real and non-real solutions, which that's what I'm thinking. The homework is just your real solutions. But let's say a standardized test says find the real and non-real solutions. Then I would actually have to take this and I would have to plug it back in here. So if it said real and non-real, and it said or any kind of solution, we would take and plug that back in, and I would get y equals 4. And there's two answers here, right? Negative 1 plus I root 3 over 2, and negative 1 minus I root 3 over 2. So this would get 4 plus negative 1 plus I root 3 over 2. And then y equals 4 plus negative 1 minus I root 3 over 2. And then I'd have to find a least common denominator. So this becomes 8 over 2. And I'd get y equals 8 minus 1, which is 7 plus I root 3 over 2. And y equals 8 over 2 plus negative 1. Again, 7. And this time it's minus I root 3 over 2. So if it found any solutions, I would have to do negative 1 plus I root 3 over 2, comma, 7 plus I root 3 over 2. And negative 1 minus I root 3 over 2, 7 minus I root 3 over 2. If it said find all the real solutions, I'm looking at a no real solution answer. If it said to find any type of solution, then I'd have to take that I and I'd plug it back in. All right, so I took the top one, I solved it for y, I moved the 2x and then multiplied everything by negative 1. So y is 3 plus 2x, and then I took that, plugged it into the bottom one. This is the first time we had to expand and FOIL. So you've got to take your 3x plus 2 squared. You can either expand and FOIL or use the shortcut, which is square the first one, square the last one, and then double the product of them. So I'd get 9 plus 12x plus 4x squared. Then you have to distribute the negative on the front to each of the terms on the inside. And I end up with this row. 2x squared plus 4x minus 9 minus 12x minus 4x squared equals 0. Combine your like terms, negative 2x squared minus 8x minus 9 equals 0. And then I had a negative on my x squared. I don't like them, so I multiply everything by negative 1 to get rid of it. and I end up with 2x squared plus 8x plus 9. When you multiply 2 and 9, you get 18. There's no factors of 18 that sum to 8. So I have to use quadratic, and when you use quadratic, underneath your radical is a negative number, which means this would be an I. That's an imaginary solution, so we just write no solution. Questions? All right, so we're going to stop here today. You can do the full assignment as it is, which is due tomorrow. And then we will finish. There's some fun problems in the next slide. We'll finish those tomorrow, okay? But you don't see that stuff happen on the homework, so you're fine with what it is.